So I'm here with Matt from Liquid. Hello.
Hello, Wendell. Thanks for having me.
This is going to be really exciting because I honestly think that what Liquid is doing with composability is the future of data centers. Now, I know if you've been following Level 1 for any length of time, you know that we love to heap buzzwords on you, but this literally, I think, is the future of data centers because it's too much work to ask system architects to do the architectural things. We could just put all the hardware in a big bucket and figure out what we need in software, and that's kind of what we're looking at here. Like if we look at the liquid matrix diagram here, it's just a big old swirling sphere of crap. Like if you look at this and you don't know what it is already, this is not telling you anything really. I can see some icons and I can see like server 1, server 2, server 3, server 4, server 5, server 6. I think most of our audience is familiar with virtual machines, but this is something different. This is not virtual machines, but the flexibility of a virtual machine stitching hardware together in software. And you're going to have to explain it better than I am.
All right, sounds good. Well, thank you for that. I do see what you're saying from the point of diagram, but
It's like what's happening in this diagram? It's just a big swirl of stuff. I don't like. Are you like this? I don't know what this means. I don't know what it means.
this is all the power of the liquid matrix, right? Our whole concept is instead of having all these servers with everything bundled in the sheet metal and literally defining what that server can do, letting the sheet metal define that. Instead of doing that, we're saying, you know what? Disaggregate all your hardware, all the devices you'd want to make a unique personality of a server. Put that within our liquid matrix, and then when it's in that liquid matrix, when we've disaggregated that hardware, we put them into this matrix, which allows software to then at that point literally create bare metal servers on demand.
So
So
you're gonna have to like you're up here. We're gonna have to go like way down here. So we've got at level 1 we've built like a GPU server and we've built a storage server, and we've got our pedestrian 1U servers which might have like 8 SATA hard drives and a couple of processors and some RAM and maybe some networking stuff. I figure a company like a pretty good sized company, they've got a rack full of servers and they might have a GPU server for research and they might have an NVMe server for storage, but sometimes I need to run an application that needs really fast storage and like GPU storage, and I got to like go over the network or something like that. This smells like it's faster. Like what's the difference here?
yeah, great question. So basically, instead of having, like I said, everything inside those servers, we're actually going to take those unique items. We're going to put them into purpose-built chassis, and these chassis are really defined or created so that I can have a low-cost solution where I can just fill up random devices, whether that's NVMe, whether that's NICs, whether that's GPUs, FPGAs, any other types of accelerators I may want to have in my environment. And what that allows us to do is really allow you to pick and choose individual components you may want to have inside your data center. And then based on your current demand, meaning I have a requirement that came up 5 seconds ago, I want to go create a server to go meet that requirement. I can send an API and literally over our liquid matrix PCIe fabric, go ahead and compose all those devices into a server and give you exactly what you want when you want it. So
So
instead of having to, yep, go ahead.
well, no, I mean it's so to understand it, it's like I've got a rack and I've got a chassis that's filled with GPUs and I've got a chassis that's filled with maybe FPGAs, and in the olden days I might configure a special they make a special 2U server that's just for GPUs, and this is kind of the old way of thinking about it. Instead of building a server that's got my GPUs and a little bit of storage, if I need both of those things for my application, and then I have to connect and deal with it over like Ethernet or InfiniBand or something. This is like literally everything is connected via PCI Express. Like there's not, it's just a direct PCI Express connection.
That's exactly right. So today inside your motherboard, right, there's PCIe Express connections all over the place, right? And in your 1U servers, you're going to have less than you're going to have in a 2U server. Exactly the challenge you talked about, right? If I want to have GPUs, I need to have a specific server today that has the cooling for GPUs. It has the right riser configs, has the right physical layout for those GPUs. Well, you know what? I want to be able to go put GPUs anywhere, right? And so what we do is you put a very small PCIe card inside each of those servers. It connects those servers into that liquid matrix PCIe fabric. And then from there, we're able to go take all those other resources and use software to say, hey, this little half-use server, now you have 10 GPUs. There you go. And I'm just going to go deliver that literally within a matter of seconds.
So I could take my dual 64 core, AMD EPYC Monster CPUs, set those down, I've got a terabyte of memory in this chassis, and then over here, I was doing some Ethereum mining, or no, I was doing some research, some research
Right,
stuff,
right.
and I just hit a few buttons. And because of the magic of PCI Express, I'm able to sort of software disconnect that from like the mining rig and actually reattach it to, whatever the research project is, or whatever like that. And it's literally just a PCI Express connection. But I don't have to physically move the cards. It's a software switch within the Liquid Matrix.
That's exactly right. So it truly is software-defined hardware, right? Literally put that hardware exactly where you want it in whatever server you want it to go meet the real-time needs using software.
Yeah, we were talking about it's one thing that I think helps me sort of visualize and understand some of the use cases is not just thinking about okay, how the hardware gets juggled when you've got a specific problem to solve, but in talking about like specific customer examples and specific sort of use cases. We were talking before about VDI and virtual machines, and yeah, I've got the 64 core Threadripper monsters, but with VDI it's nice to have a little bit of graphics acceleration, things like NVIDIA Grid, and being able to run that, and those work really nicely with VMware. But at the same time, those same GPUs, my research scientists can use those as well. And so, I'm looking in the data center and I'm looking at something that's traditional built, and it's like, okay, I've got my VDI servers that aren't doing anything 16 hours a day because everybody only works 8 hours a day. And I've got my research machines that are running, around the clock. But wouldn't it be nice on nights and weekends if I could take most of that VDI infrastructure, those same GPUs, and reallocate them toward R&D or whatever on the weekend? Or a pandemic strikes and it's like, okay, I'm going to need twice the VDI bandwidth that I had before. Everybody's working from home now. There's nobody in the office, and so the R&D team is going to have to suffer. I don't have to send anybody into the data center. I can literally just recompose those servers. I mean, through the magic of PCIe hot plug, I don't have to reboot in a lot of cases. Is what we were discussing. And so you guys called it no wasted hardware or something like that.
That's exactly it, right? Whatever scenario you find yourself in, right? You're always prepared, right? That's with VDI in particular. It's one of those use cases where we're seeing customers want to put GPUs, want to put graphics cards inside their environments. They're saying, hey, you know what? I want to do CBTs. I want to be able to have streaming video for my end users. I want them to be able to have that experience still. But at the same time, can I afford only allowing 24 users per node when I'm trying to go roll out my VDI? That's going to be very expensive, right? So with the power of composability, it literally allows you to start with a small pool of graphics users. And I didn't have to waste the investment I put into my standard users. I simply compose in GPUs on demand. So if I want to go bring some more users into my graphics pool, I move a node from one cluster to another cluster. I compose GPUs, and it's ready to go.
Yeah,
exactly like you said.
Yeah, that's a good point. I mean, a lot of those VMware, the purpose-built like VMware VDI machines that don't have the GPU requirement, those are only 2U nodes. But with the Liquid Matrix, you could just throw in a couple of really high-speed PCI Express connections, and then all of those GPUs are now available to that server that already has everything else on it. So not a big deal.
Exactly. And going back to the other point, right, of 8 hours a day, right? We have a lot of media entertainment people that love this concept, right? This hey, I'm going to have these expensive resources that are going to go into a workstation during the day. I'm going to go use that. Well, I'm on the keyboard. And then at night, let me go send those to another system that's going to do more automated workloads, right? Where, hey, those resources can be now utilized 24 hours a day instead of having two separate sets of expensive assets. Let me use them with my hands during the day, and then I'm automated at night.
Yeah, if your VFX workstation is not working, or if you're not logged into your VFX workstation, it's rendering for somebody else that is logged in somewhere trying to get their project done.
Yep.
Yeah, that's those kind of things. Traditionally, there've been different software solutions to try to manage that. Like the Adobe Creative Suite has a thing that like tries to deal with that, and like Autodesk's products have a thing to try to deal with that. But where you guys handle it at a PCI Express level, it seems like it's a lot more repeatable. I mean, I could think of use cases even in like software testing. Like you've got a really elaborate thing that you need to test. You could rotate through a whole bunch of different hardware. You're a game company. You're writing a game and you need to test across a half a dozen different GPUs. Well, just
Yep.
automate it. Have your engineers build a script to automate it. Like, all right, let's plug in an RX 5700. All right, let's plug in an RX 5500. All right, let's plug in a 6800. Just reboot you could do that with physical hardware, reboot the physical hardware, attach the GPU. There's a million and one use cases for this. And the density is pretty nuts because, you just have a rack of all of this stuff. The whole rack is PCI Express, so everything's pretty fast. And
Yep.
you can compose it however you want for whatever your purpose is.
No, no, exactly. And that's one of the other really cool things I love is this idea of a heterogeneous environment, right? So instead of saying, hey, you know what, I have to pick something like we talk about high performance computing and AI and things like that, right? You know what? Why do I have to pick one type of resource? I may have a scientist doing some pretty cool stuff and they want something just unique and different. Well, you know what? If I'm in a heterogeneous environment, like you said, I build the code once, I prepare it on the system, and I simply swap in the right type of accelerator real time. And the only thing I have to do is restart the driver and run the test again.
Yeah,
Connect it in, test driver, run the test.
you'd be surprised how often. I mean, I get to talk to a lot of people that work in the industry, and sometimes some of the people that I talk to, they treat their servers, like all the servers are named after all of the characters in Babylon 5 or whatever. And it's like servers are cattle. You shouldn't get attached to it because it's gonna have to go to the slaughterhouse at some point. And
Right.
it's like, oh, I purpose built this. I lovingly purpose built this server, and I've perfectly balanced the PCI Express resources, and I've gone in and I've hand tuned, like the NUMA configuration, and like this is pinned to this core, and this is pinned to that core, and blah blah blah. But the reality is that it doesn't make sense for somebody that is that skilled to spend time doing that when you can just buy, a white box system. Not that a lot of work hasn't gone into it on Liquid's part, but just buy a white box system that has, roughly the GPU and storage and compute requirements that you're going to have. And then as your requirements change, you can recompose. And the cost for doing that is zero versus,
Right.
Other solutions.
And going to your comment, right? And we can templatize all that work, right? So if they want to have, they have a dual socket system and they want to go compose GPUs to each socket. They want to have BIOS settings already integrated. We integrate to Redfish, right? So I could literally templatize all of that, and they could say, you know what? I want to go run this workload again, and in that workload, it's best set up this way. Send the API, right? And then that system is literally laid out exactly the way they want to, with the devices attached to the right same CPUs they want to, with all the settings set exactly the way they want, and it's done in a matter of seconds. And
it's easy to, it's easier to sort of visualize this when you're thinking about GPUs and CPUs and RAM and storage and all this other kind of thing. But the reality too is that, even medium-sized businesses are getting into doing certain kinds of specialized workloads with FPGAs, because FPGAs are, they're still really expensive. But FPGAs is one of those resources where it's just expensive enough. It kind of stings a little bit when you've got to buy them, kind of like the highest end of the GPU, the AI, and the machine learning stuff. But at the same time, you want to encourage adoption throughout your enterprise of those leading edge technologies. Maybe somebody in accounting has a really killer idea for something with an FPGA. You never know. And it's like they would never be able to get funding to do that on their own. But if there's something composable available in the pool and you're running those jobs on kind of a scheduled basis, then it's pretty trivial for your administrators to, let Bob in accounting try his crazy idea on an FPGA.
Yep. And one of the great things about FPGAs is they are field programmable, right? Is so we can literally have different instruction sets for that same card to do different things at different times. And that's one of the other really neat aspects of this is not only do we do things like reprogram FPGAs to different firmware before we compose, we can even wipe data off the devices, wipe data off the NVMe, set you up with a clean environment, set you up, move the data from node to node if you need to. Lots of different cool capabilities that really set you up to do to really kind of do exactly what you want when you want it, and it's all, like I said, API driven, so fully programmatic.
The other thing that really struck me as being really exciting about this infrastructure is that because other automation technologies, like, sometimes on this channel we talk about like Kubernetes and Docker and that kind of thing. I saw that Liquid has integration now with Slurm, so you can use this as your physical machine basis, but you can still get that containerization orchestration on top of it, because these are kind of like virtual machines in terms of their flexibility, but they're not actually virtual machines. So you've got all that stuff you can run on top of them.
That's exactly right. So running it bare metal provides a lot of advantages, right? So I don't have to worry about installing agents into operating systems, worrying about compatibility list problems. If it works installed in a box, it works composed. So it's a huge advantage that we have. And then with the Slurm integration, when it comes to HPC, it's something I'm really excited about, because HPC has been around for 25 years ish, maybe a little longer, and it looks exactly the same as it did 25 years ago, right? Yes, speeds have gotten a little bit faster, but the way they designed it, the way they put it together, it's exactly the same. And we're going, hey guys, let's completely flip this on its head. Cloud has kind of done that a little bit, right? Cloud has given these organizations a lot of flexibility with HPC, and said, hey, you know what? I can pick exactly the right system I want when I want it. And there's a lot of value there. So what Liquid did is we literally embraced that concept. We said, you know what, we are your on-prem cloud when it comes to HPC. So when we integrated with Slurm, we actually took exactly what Slurm does for AWS. We integrated that for Liquid. And literally any organization within your corporate infrastructure can now see the Liquid on-prem cloud and go engage it like you would in AWS cloud.
Yeah, for those of you that are not familiar with Slurm, I'll read you the overview. Slurm is an open source, fault tolerant, and highly scalable cluster management and job scheduling system for large and small Linux clusters. And so if you've got a little bit of experience with Amazon and some of their tools, you got to think about what he's saying in terms of the Amazon cloud and the different products they offer. And Amazon has Elastic Compute. It has S3 for storage. It has other different tiers of Elastic Compute, and you imagine that depending on how much Elastic Compute you buy, it gets it into a smaller and smaller and smaller slice of a less and less and less nice machine, and it's not very homogeneous in my opinion. Like, you can do a lot with Amazon, but you're learning Amazon's tools. And if you develop a lot of automation around what Amazon is doing for you, it's not immediately useful with, say, Microsoft Azure. Whereas if you're using Slurm or other open source tools, things like Terraform, you can take that and sort of use that in the cloud. And that's kind of, I think, the future of the cloud. And that's what edge compute, like the whole, let's talk about the edge. This is kind of, my personal opinion of it is that this is sort of where the edge is. If you look at Amazon's big customers, to get around this problem, Amazon's letting their big customers run their software stack at the edge because they don't know how to prevent the loss of control, which is going to hurt their pocketbook. But the reality is that with composable infrastructure and things like Slurm and automation, companies really should be investing in that first, and then looking to Amazon second for fulfillment as like a secondary integration tier. Again, my opinion, nothing to do with Liquid, blah, blah. Don't want to get Liquid in trouble or anything. But I love the automation and the capabilities that this puts back in data architects' hands, because sometimes you're sort of a slave to how the engineers envision it at the cloud providers. And with this, you don't have to do that. You can envision whatever you want and build it.
Yeah. Now, I mean, there are some definite advantages to the cloud, right? Cloud native apps run the cloud very well.
Serverless.
Right? Right, exactly. Right. There are some big benefits, and you can actually save money in certain areas going to the cloud. But when you're talking about any environment where you care about compute, you want high performant resources, right, in your cloud, in your environment, the cloud is generally not going to be the area you're going to go save money in. But people still want to go that way because they need that flexibility, right? They can't sit there and say, I got a requirement and it's going to take me 6 to 9 months to go buy that gear, get it put in site, get it installed, because of the boxes is different than what I already have sitting in on-prem. They can't do that, so they go to the cloud.
Well,
and that's the problem we solve.
It seems to me that if you do the bean counter approach for any of the CIOs that are watching, it's like I have to get the accounting folks to sign off on this. If you look at what you're spending in in cloud, you can probably get a reasonable buffer of hardware for anything like that pops up. But don't forget, you can still handle your burst workloads in the cloud. So, that first Thursday of the month when all the data comes in and you have to do all the crazy processing and blah, 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 yeah, use Composable and use all the automation, use all the tricks at your disposal. And if that requires 125% capacity, go to cloud for that 25% that you need. And because
Right.
that's a burst workload, you're going to spin those instances up. This is all automated. You're going to deploy that. You're going to copy the data. Then you're going to pull that data back down out of the cloud or delete it. So that's a less of a risk in terms of the information security aspect of it, which is usually pretty easy to get the executives to sign off on. But because that burst workload is handled in the cloud, you're not paying for that over the course of the entire month. It's really the best of both worlds. That's what cloud is good at, is I can give you a lot of hardware really quickly. You're going to pay for it, but I can give it to you quickly. You don't have that capital expense. And Composable gives you the same flexibility as the cloud, but without being shackled to the cloud's tools.
Yep, exactly. So if you're going to be in a very high flux environment, like you said, right, be prepared for that 85, 90% scenario with on-prem hardware that's fully dynamic, get you exactly what you want when you want. And if you have to go higher than that for a short period of time, you either plan for it with just adding a couple more resources into the pool, into that liquid matrix pool, or you send it up to a burst. Absolutely.
Yeah, that's sort of the two-prong approach that I see. Now, again, I could be completely insane. It's just my opinion, nothing to do with Liquid. But I love talking to you guys about this, because it's what if? Well, we play the what if game. What if the future? So what if, this is how it plays out? Doesn't it mean that, one, the cloud becomes even more standardized, and so we end up with basically what Liquid offers in the cloud, and so your on-prem hardware or your cloud hardware is just where you want to run that, because that's the most homogeneous, that gives you the most flexibility. And two, doesn't that reinvigorate competition among cloud providers? Instead of competing on the software features that those cloud providers offer, it's really just down to the capabilities and features that they offer, because the platform has been so standardized, and that's what everybody expects.
Yeah, that's exactly right. And we're seeing this, where you're seeing the hybrid cloud companies really start to want to engage and go, hey, I want to be able to offer what I can offer when I send stuff to the cloud, offer that same flexibility on-prem, and really give the customers the option. Do I want this in colo? Do I want this on my facility? Do I want this in the cloud? And I have all the same options. And that's what Liquid can integrate into that story.
It's I want to take credit for that, but it's really just, that's how it's always been in the industry since the beginning of time. In the beginning, there were mainframes, and then there were mini computers, and now, and so things swung out to the cloud, and possibly things will swing back in from the cloud, because even though the cloud has it in volume, because the amount of money that the hyperscalers pay for hardware, way less than you and me, way less. And they're probably more headache and more tech support too, because they find all the bugs. But having this at the edge makes so many little problems go away, because you can't get around the speed of light. And so does that mean that there's going to be a data center at every corner drugstore? Maybe.
When you look at servers today, right, you have to say I have to pack everything into a server, and if I need a little more NVMe, right? Today you're going to say, all right, I either have to go add to a storage array, or I have to add a server with NVMe in it, right? So I'm buying compute to go add a resource into my environment, right? I work with customers today that are doing 50 petabytes of NVMe in an environment, and they literally have it packed into 1,000 servers, because that's how many slots they have to fit in their dense configuration. We're going, hold on, let's separate that concept, right? Let's give you exactly the right amount of compute, exactly the right amount of storage, and then if you need accelerators, additional networking to go with it, right, exactly the right amount of that. So then if it comes down to, hey, I have more data, I need to add more storage, don't buy compute because I want to buy storage. Simply add more storage, right? Pull it in, pull that storage in, and now every server in my environment has access to it, right? So you don't have to buy more compute, buy more memory just because I want one single piece of one single part of that asset, right? No, buy exactly what you want when you want it. They even go on a credit card most of the times. Right? We're seeing scenarios where they're like, hey, I want to buy a GPU. I don't have to use CapEx. I simply use a credit card, get a GPU in here for a specialty use case. Instead of buying a $40,000 server to go let that fit inside, I got exactly what I wanted, pulled it in, and it can be used anywhere in the fabric.
Yeah, the thing that really blows my mind is that all of the traditional interconnects are no longer necessary. And there is a tremendous amount of overhead. It's like, oh, I've got 100 gig Ethernet. It's like, yeah, I've got 32 gigabytes per second PCI Express 4, x16. Like
Right.
it's just, how is this thing communicating with that thing? PCI Express. Because there's not, like, that's the fastest thing there is. Like, why would we bother converting it to anything else? It's literally
Right.
PCI Express to PCI Express communication. It's like, oh, there's I built a cluster in college, and there were 3 network cards, and it was a 3-dimensional cube of servers, basically, where every server was connected on one of 3 different backplanes because of bandwidth balancing and crap like that. And now it's just, oh yeah, PCI Express. We don't, Ethernet's too slow. Like, even 100 gig Ethernet is too slow.
Yep. I mean, and don't get me wrong, we do have a lot of that ability to go put the drivers in and make those direct connections between nodes over a straight PCI Express, give you that blazing fast performance. But I will say we definitely still work with our partners, our Mellanox and the Ethernet vendors, IB.
We
right?
can
There's still a lot of value. Right? There's a lot of value in that protocol. But what's great is I can deliver you that resource still, right? It's still a PCIe device at the end of the day. So I can still bring those NICs into you. I can give you more of those resources on demand.
Yeah.
And don't get me wrong, in the future, I think there's a lot to be said about what you just said right there. I'll leave it at that for right now. I think there's a lot of really cool things that you'll see with that in the future. But where we stand right now is we kind of embrace that ecosystem of partners, right? From NVIDIA to AMD to Mellanox and even QLogic and others.
It still melts my brain thinking about PCI Express 4 being 16 gigatransfers per second. And that's just, it's like, oh, let's add more lanes.
Right.
That's a lot of bandwidth. So a lot of these technologies, I get the picture in my mind that we're talking about, PCI Express composability, in a rack. I've got a couple of drawers of GPUs, I got a couple of drawers of NVMe, and I've got my compute right there. But there are some compute problems that won't fit in a single rack. Sometimes it spans data centers. Sometimes the LA team has got to get to work with the New York team. And then I think 100 gig Ethernet and that fiber to coast to coast fiber optic network that we've been talking about sort of plays in. And I've heard this infrastructure over fabric sort of words. What are we talking about there?
Yeah, so we've talked about PCI to this point, right? And PCI is a great protocol. It's the fastest, lowest latency protocol we can operate on, right? But speed of light has issues, right? Meaning distance issues, right? In order to maintain that latency, I've got to be kind of close.
I want to compose a GPU in San Francisco from New York. Not the best idea.
In the PCI, I wouldn't recommend that, but that's why Liquid's kind of invested in this over fabric approach. So we are doing. Working with partners like Western Digital to do NVMe over Fabric. We're actually now integrating GPU over Fabric. So we will actually, we have our first beta tests out there right now for our GPU over Fabric, where I can deliver NVIDIA cards out across campus, across cities. And yes, my latency is going to be higher, but in a lot of AI situations, that doesn't matter, right? What matters is I get the data to the GPU processes and send it back. And if that's all I really need, then it's a perfect use case to be able to go have a pool of GPUs and they'll send them out.
And that aspect of the composable fabric, we've got Mark here to talk to us a little bit more about that.
Yeah, thank you. I'm Mark Mickle. I'm the Director of Partner Alliances for Western Digital's Platforms Group. And we do have very scalable NVMe over Fabric attached JBOFs. A couple different versions of it. Most popular one is a 224. It runs 100 gigabit Ethernet, and it uses RDMA to do this. And so we get very good latency. We utilize all the bandwidth in the 100 gigabit fabric, and we can scale storage in any of these solutions that we've been talking about to an extreme level with all this fabric interconnect.
So JBOF. JBOD, just a bunch of disks. JBOF, just a bunch of flash?
That's right. You got it.
Yeah, I mean, we were talking a little bit, before we started the video, and you were talking about, something like 50 petabytes of flash. I mean, there are like spinning Rust is dead. That's a crazy amount of flash.
It is, and it's it's probably not for everyone, but there are cases where people have really big data sets that they want to do machine learning on. And they want to get access to that same data pool from maybe a lot of different GPUs. right? And orchestration is a very good way to achieve that.
Well, in RDMA, RDMA is another one of those technologies where you can literally remotely, as the name kind of implies, you can remotely access memory in a FAR system. And so with this fabric approach versus like a traditional network approach, it's a little less overhead. It's a little bit more direct access. It's a little bit more end to end. So if you do have a use case from like New York to San Francisco, and you need to ship a whole bunch of data, to be shared by GPUs that are running in both locations, you can basically transfer the entire block of memory, and the network card will take that block from the network and deposit it directly into main memory, and then it can be processed from there. And that's a big feature for lowering overhead and latency.
Yeah. So for these remote storage applications, the NVMe working group has done a great job of really simplifying this for all the users. And you do a simple install, and these remote drives, no matter where they are, they look to your OS just like they're local. And you do data transfers, you do the RDMA in and out of these drives, just like you were describing, Wendell. And it's very slick, very nice, and it works well in the orchestration environment too. At Western Digital, we've just tried to really make this simple. So we have two different versions of the data storage. We have what we call the F3200, which goes into a 3U chassis and gets very dense storage up to 614 terabytes in that 3U. And then we have a more traditional 2U24, where we get about half as much storage in it, but every drive is accessible and hot swappable and all the things that data center people like to have and expect to have.
Nice. So with this kind of sort of new architecture, I mean, would you say it's kind of a new way of thinking or a new architecture for data center stuff?
It is, and what we run into all the time are customers that are used to, I call it scaling by adding servers. So you talked about what happens when your problem goes beyond a rack or goes beyond a server. We'll start there. Traditionally, the answer is add another server, and that server is going to have some CPUs, some memory, and some flash, and maybe some GPUs and other things in there. And you may or may not need all that stuff. And if you don't, you're spending money to scale with that server that you don't really need to spend. Whereas if you can just, in the case of Western Digital products, add the flash, add as much flash as you need, and don't spend any more money on CPUs and memory and things like that. Just get the flash you need.
Just get the flash attached to the fabric, and we'll worry about it later.
Exactly.
And then, Wendell, to bolt onto that, not only do you get the advantage of not having the processor and all the spend of the hardware, but the operating system, the applications, the licensing that goes along with having those servers in the environment, right? By adding more flash into your existing nodes, I actually get more value out of that node, out of the license that I've already paid for. Right? Think about VMware and vSAN. I could expand those nodes out, the storage capacity. Oracle, I can expand those nodes out. So I end up getting more value out of the licensing payments I've already made, and don't have to go add more to that by adding more CPUs.
So switching gears a little bit, when we're talking about VDI and VMware and the sunk cost of licensing and all of the stuff that goes into that, if I'm running a kind of a large company, I can imagine wanting to give a slice of resources to my department heads. Maybe like the marketing team and the web team. It's like, all right, here is the resources that you need to run our customer-facing applications. You're going to have to get it to fit in this, or you're going to have to get it to fit in that. And for the executive buy-in, I really want to see you using continuous integration, continuous development, the agile methodology or whatever. Composable would give them the tools that they need to do really fancy integration tests, really fancy unit tests where they can just spin it up and destroy it as needed, and we wouldn't really have to buy any extra hardware to deal with that. We have the resources to deal with that in the continuous integration pipeline for those kinds of applications. I could see other departments benefiting from that as well, but it seems like the whole continuous integration, continuous testing as like a way of doing quality control inside the organization, like this opens up a whole new set of avenues on that side in terms of giving them the tools that they need to automate their own virtualization and their own testing and that kind of thing, which is a whole other thing we haven't even talked about.
You made the case that you probably wouldn't have to buy more hardware. You're actually going to buy less hardware, right? And the reason being is today, when you work in a VMware environment, right, or a virtualized environment, you're sitting there where every node in your cluster has to look exactly the same. right? All these nodes have to be outfitted with every possible option I might want to run a virtual machine on, right, within that cluster. So when you're looking at a composable VMware environment, right, I'm in a very different mindset. I'm going to go minimize what's in each one of those nodes. I'm going to say, you know what? I don't really care about having all these fancy personalities of nodes. Instead, when I go create a container, I create a VM, I'm going to go add that resource to the node on demand, right? So that way I can have minimalistic VMware cluster. And then if I want to vMotion that node, I'm just going to move the device with the VM, right? And so that's why you're going to see a lot of good integration here between Liquid and VMware, in particular for that exact reason, right? We want to go put you in a much more flexible environment where you get exactly what you want when you want it. We want to go interoperate with that vMotion type approach, so I don't have to have clusters full of every possible option. I give you exactly what you want when you want. And then you talk about the CI/CD type of implementation. You sit there and you go, instead of having to be ready for every scenario, right? Let me go charge you for exactly what you're using at this moment, right? So if I want to have a GPU for what I'm doing here, if I want to have go compose a couple extra terabytes of storage for what they're doing here, I can be very defined and descriptive and exactly what's being composed of the systems they're going to be using, and then I can give them a chargeback with that. So it's not just sending them access to a cluster of servers. It's saying, hey, here's exactly what you use. This is what you're being charged for. No more, no less, right? And so it can be very defined and getting exactly what they want when they want it.
Well, even just, that they gave me another idea, which is, if I had 3 nodes in my cluster and one of them went down and the 3 nodes had, let's say 3 GPUs each, when one of the nodes went down because it was, a hardware failure in that particular node, because it's on the Liquid Fabric, I could just recompose the GPUs that were attached to that node into the other 2 without rebooting. And then the GPU resources are available on those nodes. Now that might not work out depending on what the nodes are actually doing with those GPUs, but I at least have the option. And nobody had to go to the data center to deal with that, which I think is kind of a big deal.
And that's exactly it, right? And VMware's doing is kind of integrating with this company called Bitfusion today, right? There's an acquisition they made where they're taking a GPU and they're taking sections of it, and they want to send it out over their Ethernet environment, and that's good, right? Having this ability to take that GPU and go smaller and send it out, and what Liquid kind of bolts onto that is you say, you know what? Right now, you're looking at how do I get smaller than one, but what happens when I need more than one? Right, and that's that's Liquid's approach to this. It's, hey, we work together with VMware, with Bitfusion, and we say, you know what? Yes, we can go compose a GPU in there anytime you want. You can use Bitfusion on top of that to go carve out sections of that GPU to certain applications, and even send it to other servers if you want to. But we give you all that hardware flexibility so that, exactly like you said, I don't have to pull stuff off of a node in order to go put something else on it so we can take advantage of that GPU. I simply move the GPU.
Yeah, and that's this whole process around my needs have changed. I need to rearrange stuff, and I traipse down into the data center, and all of my lovingly hand-named Babylon 5 character servers. It's like, okay, I have to take all of you apart. I'm sorry, and rearrange hardware and deal with this. And now I can just change some parameters in a YAML file, and then all of a sudden my infrastructure is configured in a completely different way, and it's like, oh, I've got some surplus resources. It's like, well, I could sell that to another department. I could do, all that kind of stuff. The same thing happened with mainframes. Like in the beginning, the giant companies did mainframes, and then they would, do time sharing, and time sharing was kind of a thing. But with the cost of hardware and the complexity of these applications and the need for repeatability, because when I, as an administrator, am fired and somebody inherits my lovingly handcrafted Battlestar Galactica, named servers, somebody has to figure that out. Whereas if I had used composable infrastructure and there was a YAML file that defined what my infrastructure was, you get the documentation for free. It's like, how is he running this application? And it's like, well, the YAML file looks like it's got this kind of thing and this kind of connection to the GPUs, and I needed this much flash, and the FPGAs are programmed this way. Whereas you go to the data center and it's just like, oh, this server, this Cylon server was actually a hidden dependency for the whole thing, and if it's down, the whole thing is down. So
Yep.
you can't help but go towards something like a composable infrastructure. And it's really nice to be able to have this sort of, informal conversation about what if and how does this all fit together and what happens if you need 50 petabytes of flash. Like,
Yep.
do I need a special add-in card? I mean, there used to be those chassis that would have like 3 different kinds of InfiniBand and 2 different kinds of Ethernet. And it's like, oh, this connects to this fabric and this connects to this fabric over here. And, we're actually kind of killing that complexity. And
Yeah.
in some ways, it's maybe a little more complicated, but with the complexity comes documentation about your environment, and that's why I love it so much.
Absolutely. I mean, going back to the YAML file, right? That we have a node that fails. How quickly can I go rebuild that? Like literally say, oh, the motherboard just had a bad DIMM on that motherboard, right? Let me literally take the NICs, take the drives, take any other resources that were on that node, compose it to a new node, and now, oh, by the way, I've just installed ESXi version 6.7 or 7.0 on the drive that I just mounted to it, or literally move the boot drive of that old node to the new node, started it up again, and I'm back online. Literally 3 minutes, I could be completely online from a node failure and then have it back into the cluster, all on a new node with the exact same hardware. So I didn't have to have full system standby waiting. I simply had a motherboard with a CPU and DRAM, and I moved all the other resources over to it and had it running.
Yeah, in the case of like something like an FPGA, you don't even need a spare FPGA, except of course in the case of an FPGA failure. But like you have a node failure that was mapped to an FPGA, you just spin up a new node and remap the FPGA, and it just continues right where it left off.
Exactly.
That is how can that not be the future? I mean, come on.
Nope, absolutely. And then you look at the Gen Z CXL consortium and what that looks like for composability. And honestly, when I came over to this company, that's the roadmap that I saw and the vision that I saw, and I'm like, this is going to be the future of the data center. This is where I want it.
That's getting into like the hardcore computer science of it, because they're like, how can we have cache coherency across the fabric? And it's like, wait a minute, no, I mean, come on. Cache coherency, like we're chasing the dream at that point. So yeah, I don't know. Cool. Well, it's been very awesome having both of you, Matt and Mark. Thank you for your time. Hopefully this has been a reasonable introduction to Liquid and composability and what composability in general can offer, because I think it'll make my job easier wrangling the cattle, especially the cattle that has not been named, because people get attached to those.
Right.
But any final thoughts or parting words of wisdom?
No, I'd just like to thank you for your time, Wendell. It's been great. Enjoyed the conversation.
No, it's awesome.
Thank you, Wendell.
Thank you.